All right, cool. Well, hi, hello, everybody. Hello, Quack. Welcome.
Hi,
Yeah,
thanks.
welcome.
Can you hear me?
Yeah, we hear. Are
Okay,
you ready?
thanks.
Yeah, sounds good. We would love to hear about your pi calculus work and your interpreter.
Well, thanks. So, just to introduce myself, I'm a first year student at EPFL, which you may know because they developed Scala. I don't know if you,
Yeah,
yeah,
right.
it's
That's where
so it's
Martin Odersky is teaching or
yes,
professor there. Yeah.
yeah, exactly. So I'm quite new to the formal calculus and this stuff. So and I don't know how related this is to row calculus. So sorry if it may seem like off topic, but I just tried to fiddle and find a type system for pi calculus, which I just added some cool ideas that I found in row calculus, and I became I just tried to write some consistent typing rules, and I try to. So maybe you want to see my screen. So I don't know if I can do that. Can
Yeah,
I?
please. Yeah, you can.
Yeah. Okay. Let's see.
That sounds great.
I
And
think
for me, at least, no problem if it's off topic or into a different calculus. That's fun for me too. So that's
sure.
welcome.
Yeah. Thanks.
Yeah, for me also. And
So
I'm also interested. What do you find like similarities and what do you find interesting in enrolling?
in what? In
In enrolling.
Oh yeah, it's so I found Roland on YouTube while watching like your Roland hours and computational calculus videos, and so I was interested in the formalization of the calculus because it has a lot of relations with other other branches of mathematics, such as game semantics, like game theory and um, chemistry. Yeah, so we have a lot of ways to see process calculus. So from the perspective of logic, game theory, and a whole field of math. So yeah, it's really so that's how I got into it, and I just became looking for what like a formal calculus that I could use for a compiler, and I'm having trouble um, to understand the formalization of the calculus as is in as presented in the Lucius Meredith paper, which I tried to read, but I, I'm missing some parts here. So I
Mhm.
tried to find something a little bit simpler that I could wrap my head around, like easier. Yeah.
Yeah, great.
Cool.
So this is
So
looks
So
this is oh, this is MD that we're looking at here, and you have some, it looks like some Haskell code that we're going to see later, right?
yeah, because I don't know LaTeX, so I just write Markdown, and yeah, it looks cool.
Yeah.
cool. Easier for me
So
also.
so here is my grammar. So we have the same uh, constructs as in PyCalculus and a little bit in as row calculus. So we have the nil session here and the drop from row calculus, and we also have the send without continuation process. So it should be equivalent to asynchronous PyCalculus, but I'm not sure how, if it's a subset so, or something else. Yeah, I'm not
Yeah.
quite sure. But so I tried later to find some correspondences, but I'm currently reading a lot on N Category Lab, the website here, to learn more about that. But it's taking a lot of time because I don't have the mathematical knowledge to process all the the input and to understand the article. So yeah.
Cool.
And I wanted also something that was more compositional, because it seems that Erlang programs does not really divide into blocks of codes with by contrast with other programming languages, where you can just write functions and build up a program from them. So I tried to make something that we could divide into processes and then compose them in a similar way that we can compose functions in lambda calculus. I don't know if that makes sense.
Yeah, it starts to. Tell us a little more. Is that what that first production in your grammar is on line 8, that P call?
Yeah, the pickle is so I can have processes that I can call, and they don't really have a return value. They just have, oh, this should be an arrow here. So they don't have a return value. So this is actually the sessions, like it's a word I found while looking for process calculus. So specifically typed process calculus, because so this is quite close from things we can see in Erlang, except that it's typed. Yeah, it's the idea. So um, I also wanted to have a way like to gather data in a form of algebraic data types, which have fields that are identified here with the F1 up to Fn. So, and this is actually, I'm not sure to add this one, but so we have the same ideas, like this corresponds to a structure, like we can see in C-like languages, and then we have ways to fetch the value of the field with a familiar syntax here with the
Yeah,
dot.
like just the dot. Yeah, okay.
Yeah. So here is the usual typing thing. So this is actually also work in progress. And so we can quote sessions, we can quote processes. So we have let's say constructs that are lifted to the type level. Let's put it like that.
Okay. Hey, Quack, I've got a couple questions for you already, just to make sure I keep following along. First is an easy one. Can you just send us the link to this repository again?
Sure, yeah. Let me
Follow
find
along.
it.
And then my second one is, can you tell us more about this notion of session? I'm not too familiar with that.
So this is actually not a session in the formal way, but I just I took the word for it.
Okay.
So actually, it comes from a paper. Well, we have their paper on session types. Have you heard about them?
I heard it.
Yeah.
Did
So
you say yes, Tomislav?
Yeah, yeah.
Oh, cool.
Greg was also talking about session types.
Nice. Okay.
yeah.
So,
And
your session type is defined in Haskell. I was thinking that it looks like a context of of the execution. Is this
Yeah,
make sense?
yeah. Just
Yeah.
let me just send the link to the repository. So do you want it in the chat of the Discord server? Maybe like here. I just send it to the computational calculate channel on the Colab server.
Yeah, this is fine.
Oh, yeah, okay. So yeah, so it's quite different from session types because session types are actually much complex, and they hold they can represent a lot more semantics and types, and they all have like a dual sessions which you can compose session processes of dual sessions to basically cancel out and have um, something that ensures the data safety. Yeah. So here my channel have the semantics of a reference, which may be different from Roland and also PyCalculus. So I'm not quite sure how does that relate to other more traditional and let's say well-defined calculus. I'm not sure that we can represent channels by references. So my receive and send constructs actually can read and write to reference. Okay. So we can also write to field. So this is not a problem. We can have a field here, and here. So every time you see your X, you can have basically everything that's defined here.
Okay. Oh, cool.
Okay.
So you could, for example, if I wanted to send a message on a channel, the channel that I choose could be something of the form like x.y.z or something.
Yeah.
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 Okay.
Exactly. Yeah. So this is also work in progress, but so these are the types of my processes, because I basically have two type systems that are intertwined in the sense that names have types and processes have sessions, and so I'm trying to write the typing rules here, but I don't have any academic intuition to this kind of notation, so this may be a little bit informal. Yeah. And so the whole idea is that we have a communication rule, as in row calculus and PyCalculus, except that it's also true at the type level. And so the synchronization of two processes, which I call P and Q, so they will collapse if their sessions collapses to the CNIL sessions. Okay, so the sessions can reduce, and ultimately it should give a zero, like a nil session to ensure that they are dual in a sense. Yeah.
Let me see if I understood that, Kwok. I think I got it, but I'm not sure. So like if you're saying if you have two processes in parallel, one is a send and one is a receive, you have this COM rule, but we have to ask the question like, is this send allowed to receive, allowed to have a COM event with this particular receive? And instead of the answer being like, well, yes, if their channels are the same, you have this different thing that says yes, if their sessions have some particular relationship.
Yeah. Usually the send and the receive must happen on the same channel. Okay. But actually it's not defined here. But in my repository, do you see my screen if I switch desktop. Like, can you see my
I still see the text editor.
Okay, yeah. I just wanted to make sure. So let me just so I try to come up with a nice example here, which is a classic like ping server and client. And so we have the select constructs, which can basically lift the read from a field to the read of an entire record. So I don't know if, well, let me try this.
I'm not completely clear. Why do you need this?
So,
to lift the field to the record.
So this is mainly because it's easier to type and to infer, because I want to make something that we can infer entirely. So
I see.
So I'm not sure that we could have done that without this select construct. So basically what it does is if you have a channel X which has field, let's say F, you can read on this field, you can get the value and then do something else and to react to this. So this process here, it has session read on x.f, then the session of p.
Oh.
Okay, and this entire thing has just session x read and then session p. So this basically allows us to check if it's kind of a pattern matching, except that the exhaustivity of the pattern matching is ensured at compile time, because I know here every field that's read. So if I have another field G that I read and do something else, I will infer X to be of type F dot type of Y. So this is translated in the typing rules, so it's not really important here. But you just have to notice that the types are inferred inside the process P and Q. So the type of the fields, and then because we have select, we know that every field has been treated and handled. So we can Q P. So we can basically avoid to have polymorphic types everywhere, because in traditional languages which implement row polymorphism, so that means that if I do somewhere in the code x.f, I will have x to be a record which has a field f, so that is normal, except that here we can sometimes have a record that is left and which is not handled. So the select construct allows us to eliminate this remaining data that we are not handling. Yeah. Do you have any questions?
So for this thing, you need a row polymorphism.
That would
you
nice.
want to have.
Yeah.
Okay.
And so then there is a kind of dual construct which I call initialize, and what it does basically is it checks if you have initialized all the fields of a record. So this we can do it. Sorry, this should be a vertical bar here. So this means that we have a sum type, which is like you would see in Haskell. So this would look like this in Haskell. So data, my type, F, and let's say some type.
And why is this some type if you have a record with F and G for X?
For X, yeah.
Is this like a product, not a sum?
You mean in the?
I'm thinking that I'm thinking of records as tuples, as products.
Yeah.
As named products. But you're saying you have a sum.
Right. So there actually a version of row polymorphism that works with both sum types and product types. So that's called polymorphic variance, I think. So this was presented in a paper that that's called scoped labels. Okay, so it's a really nice feature because it allows you to write really polymorphic code with not much typing annotation. So yeah, so it's quite nice, and so I wanted to have them in my compiler, and so yeah, we can both have polymorphic sum types and product types. Okay.
Oh, I must ask you for this paper, extensible records with scoped labels.
Yes.
Okay, great.
That sounds like the kind of paper that I would normally hear about from Tomislav.
So just let me clarify what's about the initialized construct. So it's basically the same thing, but except that you don't check that every field is read from, but you check if all the fields are written on. So if I can do this, like write on x.f the value 1, let's put a bar here, let's write on another field and write 2. This says that the x only has field f and g, because if x had more, then we would have uninitialized fields, and that would be wrong. So here x would be inferred to just f int and then g, which is also int, and we have a comma here because it's a product type, so it's named tuple.
Yeah, okay.
So that allows us to write some weird pattern matching, and let me just write.
So this int is really like a parallel initializer, right?
Yeah, it's the dual, yeah.
But what do you mean by dual?
Well, it's not really defined because dual has a formal meaning, whereas I'm still looking for some way of interpreting this calculus in categorical terms. So, but it takes me a lot of time because I'm really new to category theory. But ultimately, I would like it to have a formal meaning. But here, I use the word dual just to indicate that it does the opposite thing. Yeah, but it's not really defined.
It does the opposite thing for select, you mean? Init and select?
Yeah, selected init do kind of opposite thing, because one reads all the fields and the other writes on all the fields.
But they're both the same in that it does all the fields, right?
Can you repeat the
Yeah, I think my question was, select and init are similar in that they both do all of those fields. So in your two examples there, they'll both do F and G.
Yeah, but select can only check if for some types, and initialize can only check for product types, because you cannot initialize several fields of a sum type. Yeah, so you cannot have, let's say, if you have data either E, A. Here I cannot have a value that's both left and right.
Yeah, right.
So I can only initialize the product type and select from a sum type. Okay. So I also have a match construct which is just a which is both of these things but combined, which means that I can read from the fields of X and then react and write on Y, and I should write a value. Well, this is not really a good idea. Okay, let's say this. Let's say, okay, I'm writing on a field F of Y, and I'm writing the value Z. Okay, so here, if I do something like this, I can have sorry, I can have a I can infer, where was it? Yeah, here I can infer both X and Y to be F a, well, let's say int. Yeah. So they are both of the same type here, but it's just a coincidence. But what it checks for is that we read from every field of X and write on every field of Y at each branch. Yeah. So then this construct has a session of X read and write on Y. Okay, and to compare, this has session X write on X, and this one is just read on X, and then whatever the session of P and Q is. Okay, so we can have a continuation, and all of these P and Qs must have the same session. Okay, so so I can't like do something when X, let's say, result, and then do something, and also on failure I can do something which has a different session as here. Okay.
When you say different session, I'm not sure that I can understand what this means.
So the sessions of P and Q here. So to clarify, this should be parsed like this. So this is a read from X, and this is a read from another field of X. And so the processes. So it's kind of like in Haskell when you have if condition, then when it's true, else when it's false. Here, the type of tr must be the same as the type of FL. Okay.
Oh, I see.
Because it must return something of the same type, so that you can then do some stuff with it. Okay.
So when you say session of P, you're really referring to I have some context where I have P. Or
Let's say, well, the session reflects like when and in which order do you read and write the references. So let's get back here to the definition of sessions here. So I can have sessions that depend on names here. So I can let's say, okay, let's see a more concrete example because okay, let's say here. Okay, so I can write a maybe type much like we do in Haskell. So here is the Haskell definition, and here is the one in my compiler, but it's really the same. So it has a field just of type T, which can be anything, and another field nothing, which is an empty record, which is the same as this basically. Okay.
Okay.
So if I want to implement fmap for this type, so I don't know how familiar you are with Haskell.
Yeah.
So if we want to write fmap for this type, we have to, well, first we need to have a mapping. So I'm defining this by saying read some values x and y of type A and B. So this is a generic function. So it is we can have all types A and B here. So it's polymorphic, and because it's a mapping, we should read from X and write to Y. So this is kind of a way of embedding this type in a session, yeah. So it reads an A and it writes a B, yeah. Is it okay?
So in a sense, this is like a common event because this is like a function, right? But
well, yeah, this should be parsed like this. So yeah, it's not very clear here, but this should be the session of well, when I will call, let's say f a b, this will have type a read and b read and b write, yeah. So we can substitute the occurrences of x and y by a and b when we call the process. Okay. So I just have something in my type system which allows me to have types as parameters. So I just use a quote here, but it's not really important. So this means that I should have a type here. So this is a session, and by quoting it, I make it a type. Okay, but it's a detail. Yeah.
So the arrow in your type.
It's a session, right? The arrow in the session.
Yeah. So this may be not a good symbol, but it just means that when you call the process, you get a process of this session back. Okay, so we don't need the parentheses here. So if I want to implement this function, so we have this. And here we want a function from maybe A to maybe B. So if we translate this arrow which we have in Haskell into the form of a session, we should get mx that you read and you write on my. And it turns out that if you want to implement this, you can only the name mx, and then you can read the fields independently. So I can receive on the field just and get a value, and then I can let me think. Okay, so yeah, we cannot really do that because, well, let me start with the nothing case because it's simpler. So I receive an empty record on the field mx.nothing, and if it is the case, I just write back nothing on the my channel, okay? But then we can do something weird, which is this. So here we call the process f here. So if we type this, we get back mx just, my just. So this is the session of this process, and then I can do here mx nothing, my nothing, okay. And by putting the select, I can simplify this session, which would normally be translated into this plus, which is the choice operator from PyCalculus. So we could get it into one or another process, but it's we don't know at compile time which branch this is gonna execute. Okay, so if I apply select on something that has this session, I just get back mx read, and then I have my choice operator well, yeah, it's my nothing plus my just, okay. So this is not well typed because here this session is not exactly the same as this one, and so that's why the match is here, because you can simplify this one and these ones at the same time. So if then I do this, I will have indeed a process of type mx read and my write. So this is actually well typed, and it already type checked. So the idea is to avoid having a choice operator in the session. So you have a simpler type system. So I don't know if it's it can like, I don't know if we can express the full linear logic and PyCalculus with this, but it's it should be a subset. So that would be nice, yeah. And so do you have any questions about this? Which is like I can read from what my cases in my match here are processes. So I don't have like in Haskell where I can do case mx of this, because here in Haskell and other functional languages, I have here a pattern which is fundamentally different from an expression and a value. But here, because I can express types that expect some value and not write, well, it's not very clear, but in type theory, we can have, let's say, this kind of type, and let's say type predicate A, okay. And we can say that A here is in negative position, which means that it's basically left to a narrow type. And it turns out that I can express this more generally with process calculus, because reading from an A is just this, and then write on something of it's kind of more general, because you can really express something like this. Well, this you can, and you don't this, okay, sorry. Okay, so we can have a server which is just a database which product, which well, we have also a client that has a cart and wants to buy some product, yeah. And so we have request and response from the server and to the client, yeah. And
so when
it
you
can
call
handle
up the server,
them.
I want to just slow you down for a second to make
Yeah,
sure
yeah,
I'm
sure.
following all of this. So this is modeling some kind of like store or something, and so
Yeah.
you can call up the server either with one of two types of requests. One is like, hey, tell me the details about product number whatever, and the
Yeah.
other one like, hey, just making sure you're there.
Yeah. So that's precisely what these fields do. So when I just have ping and not a type here, it's just mean this. Okay. So it's
okay.
it just yeah, it's not really important here.
Okay.
So I can then write a process that handles some request, and then write back a response for the client to handle. Yeah. So I use here the same select construct, which allows me to know which field is which kind of request this is. So it's kind of like pattern matching, and then I write on a response. So I just want to make a clarification here, because I said that in a select process, I should have processes of the same type, which is not the case here. Okay, and that's because I should have a notion of subtyping in this type system, which means that 0 is a subsession of every other session. So here 0 is a subsession of server of this, okay?
Yeah.
So this is well typed because 0 satisfy this property.
Yeah, so you can call it that property on the right of the arrow then, right? Or is it, you can call it that session. What was the question?
Like you can write this because 0 is a subsession of this one, which is the session of this one.
Right.
Okay.
Right.
But this 0 is not a number, it's not integer,
no,
right?
No.
It's like a start, it's start process.
Yeah, so
okay.
I don't know what symbol, but yeah.
Yeah, that's fine.
Nil in row.
Nil, yeah. And so we can do the same thing with syntactic sugar, but it's not really interesting here. It's just a nicer way to write it down.
Okay, so hang on a second. Which two things are you saying are the same here, but one is syntactic sugar?
This one.
Oh, okay. So request.
So I just have okay, no, this is not syntactic sugar. I just messed up because okay, here it is with the syntactic sugar. Okay, so here I just have I can just put the new inside the process instead of just declaring new in
that's
another
great.
process. Yeah. So I don't know if we can do that without messing up the typing rules, but that would be nice. Yeah.
Yeah.
But here I was just wondering if we should have a session that reads on the server here or just on its database. So the sessions differ here because instead of passing the database here, I just read first and then send the database to map.lookup.
Right.
Mm.
So I don't know if we can. So basically, that would mean that I don't really know how that would come up in an actual example where, well, yeah, I'm having trouble to say which one should we use.
Yeah.
So I don't really know, but yeah.
And then, when you select, when you made select, for example, for request,
mm-hmm.
and you have two fields for request, right? Product and ping.
Yeah.
And this is pipe in between, and you have a comma between each of the expression.
Yeah.
What is the meaning of comma? Like this will be executed in sequence, or
yeah,
or it's more like a par operator.
So the comma is just defined in the read process. So in PyCalculus, this is just written. I think it's
a dot.
Yeah, it's x read and x read to okay, and then a dot, then p. Yeah, it's I think it's this syntax. Yeah.
Oh, it's like a continuation. It's continuation.
Yeah. Mm-hmm.
Yeah.
Oh, so how can you have multiple continuations?
So
because P itself can be a listen action that has its own continuation.
Yeah. Well,
continuation, read continuation.
Yes, and I don't have a continuation for writing to processes to channels, as I want something that's asynchronous, and I believe that the definition of asynchronous pi calculus doesn't define a operator that has a continuation. So I don't have this. Okay.
Mm-hmm.
Joshi, for this I was referring to asynchronous. You know, there is no continuous send.
There is, well, yeah.
I had a conversation with Joshi, and I was saying for this example that you spawned multiple processes in part.
Mm-hmm.
Yeah.
So when you send something, this is like asynchronous. That was I'm saying.
Yeah. Oh, I got you. Yeah. I got you. That makes sense. Yeah. By the way, tangent, but I liked your process for spawning all of the processes at once instead of giving some of them a head start.
Cool. Now I have an example that I collected all the numbers in pairs in one list.
Yeah.
So like a randomizer.
Oh, cool. I believe that was in the previous video conference. Like you talked about this problem of spawning processes. Yeah, I should check it out, but I haven't yet.
Yeah, cool. Okay, cool. So I'm starting to get a sense of how this works, Kwok. I'm curious, like how much is implemented, or can you show us some like little demo so I can really start to see how it works? Like, oh,
yeah,
a lot.
I just have a bug, so let me clone it back.
And you're really talking about type inference, and
Mm-hmm.
you're not concerned about like a execution, right?
Not
this
yet.
Is another part. Okay.
Yeah. So I just wanted something that's close enough to pi calculus so that I don't have to worry too much about these. But I don't know how well this works with the traditional pi calculus definition, like for a process reduction. I don't know if we can apply the same rules to my type system. I'm not sure. But I don't have a parser yet, so I just write. Here it is. So I just write my processes by hand. So it's not really readable, but
you just
it should
typed
work.
this whole AST you're saying, right?
Yeah.
Yeah. Okay.
And this actually should type check. So let me just do this. Okay. So this is I have the process here that I defined in my example with fmap on maybe. This corresponds to this process here.
Okay.
And it should type check. So yeah, it's taking a lot of time because I have a lot of JSHI extensions, so it's taking a while. Yeah. Okay.
But you are using micro lens, which should be faster than the whole lens. I didn't use it, but I don't know. But I read it. This is the case.
Yeah.
So is it true or?
So
what was that you're using? What that should be?
I'm using microlens, which is a lightweight library for lenses, because the usual package has a lot of dependencies, and it's just yeah. So here I think So here we have the inferred process. So let me just show you how how much typing annotations I wrote for this one. So I just have a typing annotation for the mapping function, because that's quite hard to infer, and that's because my process have the shape x, t, and then some session, and so this is different from having an arrow from a type to another, because the channel is named. So that's quite complicated to generate names without without collisions with the already defined names. So I don't have yet inference for this kind of session. But if I just provide, okay, so let me just write, sorry, oops. Can you see on the dark screen here? Yeah, okay.
Yeah.
So this is map maybe. This is basically what I wrote. So here I have select, which should be match later, makes my. So here I can have, so that's basically the same code as before. And fmx just okay. So here in this process, I just wrote the type for the f channel, and the rest is inferred. Well, let me run it back, because yeah. No, it's not. Okay. Okay, I think I know why. It's not the right one. Yeah, it's not the right file, sorry.
Oh, no, no problem.
So here, it should be this one. Okay. Map maybe, okay. So here, I should get the type. Oops. Okay, so yeah, it's quite complicated because I generate a lot of type variables while my inference infers the whole process. But this is almost what I'm expecting, except for this polymorphic record extension here, and then all the type variables here are quantified. So the where is equivalent in Haskell to a for all on types. Yeah.
Oh.
So it's kind of the same if we wrote fmap equals for all a b. Okay, so I can have for alls, but I don't have yet higher order polymorphism, so I can't represent this kind of types. Sorry. I can't have this kind of types in my language, because that would require a lot more complicated algorithm for inference.
Oh, you mean for higher kind of types?
Yes. Yeah.
Okay. I just wanted to ask you that.
But so.
But did you think about it? How can you implement it? Because I'm very much interested in that.
I found some resources about this to infer them in a functional language, but I'm wondering if I could apply the same algorithm to my type system. So
yeah, this is like a process of defunctionalization, right?
I'm sorry?
This is a process of defunctionalization to be able to like, yeah, to be able to have this maybe type just as a label and not with this a polymorphic.
Oh yeah, so oh yes, so you want to
I read this paper and I was playing with this how to lightweight higher types. I think this is the name of the paper. Yeah,
okay,
exactly. Something
yeah,
like that.
so yeah, this is a natural transformation. So we usually write this, okay, and
Yeah.
we should be able to write fmap. Well, no, fmap with f here should have this type. No, it's not this one. No, it's not the right one. Okay, this doesn't work with fmap, but if you have monads, you can basically do so T F T G. This is you should be able to do this. Functor F. Okay. And this is called lift trans, I believe, in the MTL library. I'm not quite sure, but yeah, I think so. Or maybe it's called hoist. Yeah, I forgot, but
I'm not sure. I'm not sure.
Yeah, it's sometimes used, and I wish I had them, but I don't. But I'm more focused currently on working out how recursive session work, because I don't know if we should be able to have recursive sessions or just having a forever here. That would just mean repeat a session forever. So I don't know if it's equivalent or weaker. I'm not sure yet, but that's what I'm currently trying to figure out. And we should.
And why do you think forever is enough?
I don't think so, but there should be a lot of processes that which type can be expressed in this type system. Like it's really likely because I found like 2 days ago a paper that was doing a type system for synchronous pi calculus, but like which much more closer to linear logic than this one, because which was my initial goal, like writing a type system that was equivalent to linear logic. So this is absolutely not equivalent, and this is a lot weaker than the type system that is presented in my paper, in the paper I'm reading. But it should be a subset, and that's why I like to fill in this this part in the next days.
Cool. And do you want
what some of the next steps were?
I'm sorry?
I was just going to ask if you had any ideas of like what your next steps were going to be. That kind of answer.
Yeah. So first, thinking about like if I should have in my session something like where is it? This one. So in type systems, you sometimes have a mu combinator. Yeah. So then you can express recursive sessions in the in the type system. So let's say list A is just nil or cons A list A. So if you have this type mu, you can say that list A is just I'm not sure how it works with recursive type. Well, let's just take a simpler example.
Or you mean to extract a recursion as a parameter?
Yes. So if we have this, you can write nat equals mu something. Let's call it r, and then 0 suck r. Okay. So this acts like a type constructor, and then it's a fixed point. So this types looks very much like maybe, like maybe is just
like 0 is
nothing.
your nothing. And
yeah. And so you can write with this mu net is just mu r.
Oh,
Maybe r. So
cool.
you can express a lot of recursion, and I think you can express all of them. I'm not sure. No, you also have another combination which is called new, I think. So you have the least fixed point, and I'm not really familiar with these, but maybe Tomislav knows.
We were
better.
just talking about that related to modal logics.
Oh yeah.
Yeah, Isaac and I were both working through this modal logic course on Coursera, and that is definitely the spot that I got stuck at. Like before that, I was learning and moving along, and that was the spot where I felt like, wow, this is really tough and going to take more brain power to understand. So that's very timely for me, at least.
But for me, it was also very helpful to see this like in functional way, just as you showed, because these are you can write in Haskell as a parameter, like a normal polymorphic parameter, right? Without recursion, and you can play with it the same way.
You can express the mu combinator with a type in Haskell, so you probably
fixed
in this, So let's fix f here. Okay, so this corresponds to the mu here. So then we can write nat it just fix maybe.
Yeah, and nat this nat with abstracted recursion is really just another parameter to nat, right?
Yeah.
So you can supply it to fix.
Yeah. So in the recursion schemes package, you have a lot of example of this kind of data type. So it's really enlightening.
I think that you already have it in like a reference in your project for recursion schemes.
Oh yeah. Well, in my Cabal file, I just have them, but I'm not using them yet. But I want to maybe in the pre-printing. No. But
I didn't find it, but I want to ask you for what do you plan to use it?
Okay, so I saw a repository a long time ago where someone was implementing a compiler where the whole abstract syntax tree was represented as a base functor. So let me just show you in another project. Oh, no. Okay, here. here. Mm,
Oh, I've seen this in your GitHub report.
yeah. So this is a newer version, so it's much no, it's not this one. It's much cleaner than the one that's on my GitHub. But here on my AST, okay. Okay, so this is really complicated, but let me think, because I think I have a branch somewhere. Can I just quit here? Because I can't access
Yeah.
the options. Okay, new terminal.
Oh, nice.
Can you see? Yeah, okay.
Mm-hmm.
I don't have a Git here. Oh yeah, it's here. Okay, okay, fine. So here I represent my abstract syntax tree with a base functor. So then if I want to get an expression, I can just do
Can you
type X.
say for a base functor? I'm not familiar, but
Yeah, the base functor is well, in the example of nat, which is just 0 or soc of nat. Okay, you get the base functor by taking the right hand side type and replacing all occurrences of the type that is currently defined by a type variable. So if you do this here, you just get SA, and then for all.
We were just talking about that. Okay. I see.
So this, which is equivalent to maybe A, is the base functor of nat, and you can just do this mechanically by replacing the nats in the expression of nat. Yeah, it's not very clear, but here in an AST, you usually have like data exp equals var.
Exactly.
Yeah, it's not really.
Yeah, and usually I see F for this.
Yeah, you have these kind of things, and here the exp is actually a type variable, and so if you want to get back the same type here, but with exp here replaced by by this type, you can just do fix exp f. Okay, so you should just ignore this, and so if you represent your AST by this method, you can express type inference, type checking, and pre-printing, and even parsing, I think, by recursion schemes.
And you say that this expert is a base functor of expert F.
No, it's expert F, which is a base functor of expert.
Okay.
Yeah. So in the recursion scheme library, you have a type family for functors, so which is defined. I think it's like this. Okay. So you give a type, and it gives you back the base functor. So
cool.
So I can write like type instance base nat equals maybe, which has kind star arrow star, because it's a type constructor. So this is used to write recursion schemes generically without having to know the representation of the type, and you can have a lot of So you have a base list, it is list F,
Oh, I see.
which is defined like this. So again, you just replace
All the recursion with the part.
yeah, so const AB.
I was thinking exactly the same thing. How I want to move on with my implementation. And do you know if you have two? I also found a paper that they are calling this type level. Type level something, I think. And I have a question. If you have two types, they are saying that you must define your own functor for these two parameters, two types. If you have two recursions, because in raw calculus, in Golang, we want to have two parameters for name and for process.
Oh yeah, so you want to have a fixed point for both points, like data, exp, process, and name. And then
exactly.
you want to do like input on name, and then a process.
Exactly.
Okay, yeah. So I don't know. It's an interesting question.
And on top of that,
sure.
I want to use recursion scheme, but I don't know how to do it. I don't. So
Yeah, I don't really know how we could do this because then you would have your base functor. You should have a bifunctor. So
yeah, exactly.
yeah, so you may be able to define like let's say fix 2 of f, which should be bifunctor. I'm not sure. Is it possible to write this? This should work because yeah, I'm not sure, but maybe if you have JDTs, so
so in their example, I will copy paste in the chat. Oh, it's not very
chat here. Okay.
But so, you see this mapd and seqd. This is what they are saying.
Okay. So
but but I don't want to like take the direction.
I don't have much to say left because yeah, it's still a really work in progress, and I'm having a lot of trouble to understand the literature behind what I'm studying because it's really hard and clearly outside my mathematical skills. Yeah, but so your problem in that you sent in the chat that, was that
this is from this paper.
Okay, yeah.
This is the name of the paper.
So, okay, yeah, okay. Yeah, I'm not really sure to understand here what you want to. Okay,
but yeah, I want to see. You wanted to show us your use of recursion schemes.
So, oh yeah, but if I take your data type here, let me.
No, I mean in your project, what you are using.
Well, with
recursion schemes.
Well, you should be able. Well, it's not really pasting well. So here you should just be able to do like so. This is exp f.
I was more thinking that you show us like your code. that you are using
Okay.
recursion
Okay, yeah,
schemes.
sure. Here. Okay, so
Because I was reading about recursion schemes on many different like places, but I never use it. So
yeah, so here I'm using it for 3D printing, which is the simplest example because it's just a data. So it's
it's like fold,
what
right?
yeah, it's a more general fold that works on every on every functor. So here I have node, etc. because my node type, which is defined, I don't really know where. It's a really old code, and I don't remember all of it. So
You said kata works on any base factor or functor.
it works on every functor, no, on every type that is an instance of the recursive type class, which must define a base functor.
Okay.
So here the internal value of expert here is replaced by the folded value up to this point. Okay, so if I want to pretty print something, when I pattern match here, the arguments of the constructors are already pretty printed, and I can just concatenate it with this. So I don't have to write, let's say, pretty. Well, it's called show st here. Every time I have an expression. So this is actually minor improvement compared to a code that would do this recursion explicitly.
Yeah, that's what I was just gonna say. Like, it somehow implicitly knows to recurse over every one of those.
Yeah.
Like, it's gonna do it on owner and then also on like text statter later.
Yeah.
How does it know which ones to do it on, or just it does it everything?
Well, basically every time it's let's say here I have owner arch here. Okay, so when I write this, so here it's supposed to be let's say I want to write x.f in this syntax, so I believe this was var x f. Okay, so here is the AST represented by the recursive AST, like the fixed point. So
Okay.
you just have to write fix everywhere, but it's quite the same, yeah.
Mm-hmm.
And basically, what Kata does is, given a function from x per f a a to a, it will apply this function at every recursion point on the structure. So it will give you this at x, okay, and then it will pretty print this function. So f here, then f. Okay, so it will apply this function on every sub expression of the tree.
Oh.
Okay.
Oh, cool.
And
Yeah,
so
that's great.
you have a whole family of functions like this that can express a whole range of recursion patterns, let's say, well, scheme. And I think I'm also using it for my type checking. So where is it? Analysis, type checking. I think it's here. Okay. So here I use something in the recursion schemes X package, which provide a function like this. So let me just write the signature of Kata here. So basically, it takes a functor. Okay, so this is the signature basically of Kata, and then you can have something close, which works also for monads. So you can have FA, MA, XF, and it gives you back an MA. Okay, so this is used to represent my inference, because my inference is happens in a monad that I define here. So I need a way to recurse over my AST and infer every sub-expression before inferring the global one. Okay. So concretely, this is not yet implemented. Okay, yeah. So I have a lot of annotations here, but it's not really important. But the important thing to notice is that this function defined not here. Okay, type check program. Okay, this is really bad code.
And this inference is somehow similar to your example in.
Yes, so I could use the same technique in my current project, but the problem is it actually becomes quite complicated, because in my types AST here, I have a labeled AST type, which adds some more data to every expression and sub-expression to a tree. And so concretely, we would have the position in the source code of the expression that will be stored here. And I also wanted to have a single data type for my AST during multiple phase of the compiler, but that turned out to be really complicated to maintain, because I had to write transition tables, and this became unmaintainable. But maybe there is a right way of using them so that it's not too complicated to use. But so yeah, I'm the kind of person to use more libraries than needed. So I just wanted to get used to recursion schemes like you, and it made my code less maintainable than I hoped. Yeah.
But I also want to like have simpler data types.
Yeah, but maybe there is a right way. Again, in my experience, it just turned out far too complicated to. It's mainly because I have multiple stages of my compiler, which is the parsing, the type checking. Then I want to do the code generation, which also could be implemented as a recursion scheme, I think. But
did you think about? So you have different stages, right? And you must transform one data type to another, right?
Yes.
from one stage to another. And ideally, it would be like if you can just skip all the intermediate type generation, right? So I was thinking in that kind of way. How can I, for example, use a lens to create intermediate data types only that I needed between stages? Does this make sense?
I'm not sure, but do you mean like forgetting the current data that is annotated through the AST temporarily?
I was thinking that is it possible to define just the lenses and not the real data types?
Just the lenses.
Yeah.
Okay.
So,
well, that kind of sounds like church embedding, church encoding. Do you know about this?
Oh, you mean like SK calculus or?
Can you repeat?
Do you mean on SKI calculus?
Oh yeah. Well, it's not really the same, but if you have a type maybe A. Okay, let's just do this for net again because it's simpler.
Yeah, this is the context that I know of the church encoding or church numerals, I guess.
Yeah, but it kind of looks like what Tomislav is describing because it just turns your function in your type into a function type. So here, I think I'm not really sure, but
so you have functions for both constructors, right?
Yeah. So it's.
I think this is the exact thing that Wadler was explaining in his presentation for smart contracts. Did you see this video? I was posting
so, no.
channel.
No.
It is very interesting because he was exactly talking about these problems about abstract data types and data constructors, and he was explaining the church encoding and another encoding that solves the problem for previous type, not only successive.
What presentation was that?
I posted in a computational calculus channel on Discord.
Okay, cool.
From Wadler, Philip Wadler.
Oh yeah, right.
From to what channel did you post the?
On the same channel, computational calculus. I can.
I don't see it.
It wasn't. It was from the 13th, I think. It's back.
Oh yeah.
Okay.
Yeah, it's almost on the beginning.
Oh yeah. Okay. Well, I check it out, but it really looks like church encoding because lenses describe data types as functions, and the type signature looks quite similar if you compare. So let me just look up the church encoding of maybe because I'm not sure how to do this manually. Okay. Okay, so I should be able to do this. Okay. AR. Okay, so this should be the church encoding of maybe, and what lenses give you is basically the a function like this that allows you to turn a value into a maybe a, which is just okay, and it gives you back a function that so it's a prism. In lenses, this is described as
optional. Right.
I haven't used prism much, so I don't really know how do they call it, but it gives you some way of mapping the inside of maybe. So
they're saying that prism for some type, right?
Yeah, for just and nothing. So if you extend these signature, well, the R here corresponds to the nothing, the AR here is just, and the constructed type is R here. But it's so you can always write functions like this to
yeah, what I was explaining, that you can get like a case expression with this encoding, right?
Yes. So I'm not really sure, but maybe if you try to write instead of an arrow here, if you write a lens or a prism, you can get back. Yeah, I'm not really sure of what I'm saying, but maybe you can represent your data type with lenses through this method.
I see.
I don't really know. Well, it's highly speculative, but
yeah. But for me, this sounds like interesting, because I don't want to have like this many data types that I must, like, in each stage I must like copy data.
Well, so you want to use lenses to represent your data type, like
yeah, in a similar sense, how you use lenses in your project to select type on your how you use lenses to select which map you want to use, right?
Oh yeah. Oh yeah. See, so I believe
That was to me interesting, and I found this similar to how we want to find names in Rolling.
Yeah. So if I take the code here, so you want to have a generic lens that allows you to map some kind to a mapping between names and their values, or like I'm doing here.
Yeah.
Where is it?
Hey guys, I'm gonna jump out because I've got to get going. But Kwok, thank you very much for touring us through your code and your project. Very insightful.
Thanks.
Yeah. See you guys later.
Bye.
Bye, Josh.
So I'm not sure. Okay.
You're using when you call free or
free
fresh.
It's not really used here.
Yeah.
So basically
you can
I just have in my inferable type class a lens that takes let me find my, I haven't touched my code for 10 days, so I kind of forgot, but
Yeah, it's here, right, in variable, right.
Okay, yeah, here, okay, thanks. So here I can have a lens that associates the state of my, no, it's not inferable. Okay, it's in contextual. Yeah. Okay. So my inference has a read-only context is passed through the inference to sub-expressions, but you can modify it on a global scale. So that's why I separated the context from the state.
I see.
And so if you have the context, you can always get a mapping from string to your types. If you give some k, which is given either by a proxy here or a type application here. So this is not really clean, and I wish I found something cleaner, because I just have to carry this ugly type, which I don't really want. But yeah, I think it works. But you wanted to
So I was thinking that in the sense of execution, because I want to for now I didn't think about types really. I was thinking how to represent the tuple space for rolling, because I want to match different names, and it would be nice to have something like context like you have, defined. So
okay, I'm not sure that you can do the same at runtime. So because this is just for type checking, and I don't know, like if you could have the same system, like you want to store names on the tuple space. Well, the tuple space, if I understood correctly, is just a big set of names. It's kind of the database of a rolling program, right?
Yeah, this is like two maps, one for produce and one for consume.
Okay, right. So you would want to have a lens that goes from I'm not really sure. Could you give an example code of something that would use the tuple space?
So I didn't think about this very thoroughly.
Just any arbitrary writes and reads, right?
Yeah.
Yeah.
But how would you like in your code to represent them through lenses? Like you would have
Well, I would like to represent the whole data structure as a lens.
Okay. So the tuple
for
space.
The inputs, outputs, yeah.
Oh, yeah. Okay. Well, you can have okay. There's a library in Haskell. It's called these. It just defined like this. Okay. So it's kind of an extended version of either, and then you can use it to like maybe okay. So here you can have so the this constructor would mean that the name is read from, and the that constructor would mean that it's written on. Okay. And I don't know if you could have both at the same time in a tuple space. I think so, but then we have communication that happens, right? If some name is both in the send and the writes mapping.
Yeah, but you also can have a context around the name that can cause com event. And
okay, so just to make that clear, the name can carry the continuation, right? So we would have this process. When it's read from, you continue with this one.
Okay.
Is it possible to model this like with this data type? Like, can you, okay, this should be map string, but you don't have lens.
But what is the string?
I don't really know.
What do you represent as a string for this map? Because I want to have a map that the key is a name.
Okay,
right?
so, okay, right. Okay. So, but you want, could you tell me how your tuple space is represented in the current implementation?
Well, I didn't implement it tuple space. That's the
okay,
problem.
yeah, but conceptually it could be represented as a mapping
from name to process.
without lens. So from names to what?
From name to process. This is a one map, and another map is from name to continuation.
So name to what? To
process.
Process. Okay.
Yeah.
And another one
is a name to continuation.
And the continuation would be implemented like how?
Continuation is really also a process.
Yeah.
Which represents a process with the whole, with a process that has
yeah.
pre-variables.
Mm-hmm. So well, this is equivalent to a mapping from name to these process continuation, right? Because if a name is in the first mapping and not in the second one, this would be a mapping from this name to this, like with so I'm not sure how to explain this, but if the name is present in both mappings, you have a these type, these value that stores both the process and the continuation.
Okay. Yeah, you can have a one map and store the two.
Yes.
Okay.
But I'm not sure how you would use lenses in this context, and I also don't know if this is more efficient on the implementation.
So I was thinking that I need to specify like substitution and rewrite rules and this kind of stuff on the existing data types. And I must define different data types for each stage, right?
Okay.
And I was thinking that maybe I can define not the data types for each stage, but use lenses for extracting the data and match on the or things that I want.
Okay. Yeah, I think I can think of something, because if your expression type is so let's say you want to represent lambda calculus, okay, which has a syntactic sugar, and at some stage you want to desugar this to have a simpler data type, okay. So if you write, let's say in Haskell, you can write a if statement, and that's represented in the AST as this constructor. Okay. And so maybe you could, so you would want to make this disappear at the when you drop the syntactic sugar, and so you can write just lambda boolean, well, case b of, okay. So if you want to do this to translate the if it's okay, you can express the if statement in terms of case. So you may want to 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 have a lens, basically the sugar, which would be expr, and it would, well, let's say lens like this, and you would implement this with get and set. Okay, and there you have a case expression b, then you have the patterns, so true pattern, okay. And when you set, you can also write yeah, I'm not really sure how you would implement this, but you can write not sure. We can write a lens for this. Maybe it's a prism, but what matters here is that you can write a lens or a prism that would actually do and transform your AST. And so if you have a more complex data type where the stage is a type parameter, so you can have data kinds. So you have a stage which can be parsing, type checking, etc. You can do with JDTs. Okay, this is a variable, and this would be a parsing. Okay, so what this means is that the if expression can only exist at the parsing stage.
Oh,
Okay,
cool.
I'm not sure, but that may be a solution. Then you can have any stage for a function application.
Hmm.
Okay, and so your length would be from any stage to a
Oh, I see.
to desugaring. And then in practice here, you only have parsing here. And so maybe it's not really bidirectional, so you can't modify a subfield of the if here and get back a sugared expression. I'm not sure if that can work out, but maybe it's something you can use, yeah.
It is interesting that, yeah, I made example for with JDTs,
Mm-hmm.
and where I'm defining rolling like rolling data structure for processor names. And I was converting, and I was having different data type for processes and different for names.
Mm-hmm.
And so I wanted to have this recursion between names and processes, and I can write it as a JDTs in like very similar as your expert. That I have another parameter to say is this constructor returning process or name, like expert P or expert N.
Okay,
So I have
yeah.
another data type like your stage that are saying this is name or process. So this is interesting to see that this is used for like different stages.
Mm.
So
if I believe that if you use GDTs to represent both names and session and processes into the same data type, you can basically collapse the. You can take the fixed point with just one with just one type variable, because we were trying before to write like fix 2 of f, which is f. We tried that a few minutes ago, but if your f just has one type variable, which is the case of when you have recursive GGTs like this, so row a let's say send row name
exactly.
Row name, and then okay, no, so it's lift. I think it's called like this.
Yeah, I call it output.
Process. Well,
Yeah.
you have lift and output.
Yeah,
So
it's
lift.
in send is only one name.
Yeah.
Yeah.
Exactly. And you have send, no, input, which would be
two names.
Row name, and a process, right?
Yeah.
And that gives you back a process.
Process, yeah.
Okay, so maybe if you use something that's close to this, since you have just one type variable, maybe you can still apply the same fixed point combinator and get, let's call it, well, yeah, rho
I
x.
see. And
I'm
I
not
can
sure
use
that will work.
recursion schemes with this type, right?
Yeah,
Hmm.
I'm not sure, but it may work.
Yeah. I will try that. Yeah.
Yeah.
Because I have another question for your project. I was first I was thinking that where you're doing some kind of a com event, but this is all about type checking, but it was very similar to how you search for names. It's very similar to how you search for com events. So I was firstly confused how you have like a session types and names and what they are mean, but they're very similar, right? Your types and names.
My types and my sessions. You mean? Can you repeat your question, please? Because I'm not sure to.
You're searching for the correct name, right? That has
yes.
specific structure, and this is this defines the type.
Right. Yeah. So for the com events, I'm looking for this. Are you talking about, yeah, so I don't think that I'm currently implementing com events in my type system. So if I take back my file here, no.
But in a sense, when you're searching for a type, when you want to unify type or infer type,
yes,
you're doing the really like a similar thing as a com event. You're searching for some name, right?
Yeah. Could you tell me in which unify function are you talking about? Because I have unify for both types and sessions and record types. So I have a bunch of unify functions.
Yeah, and what are the difference between these unifiers?
Well,
for example, between session and I'm not sure, session and names.
Yeah, between sessions and types, yeah. So in the paper that I just started reading yesterday, they basically use the same. They don't really have a difference between types and sessions. So they just have a single system for both, which is much cleaner. But here I just made an artificial distinction between the two because it just simplifies my type checking, first of all, and but for I'm not quite sure what do you mean when you say that it's similar to
between session and types.
Yeah.
You answered my question, but okay. How is similar? This is not exactly similar, but I'm thinking about how to implement a tuple space, and I'm just trying to find some ideas on how to do it, like elegantly, you know.
Well, here it's not really clean because my processes and types share the same environment, and I don't know if they should share all of it or just some part of it, because like my sessions depend on names, and my types can depend on processes, because I can quote a process and get a name which is quite different from quoting in Erlang, because I cannot send to a quoted process. Okay, so I can only send on values that on channels that are passed as parameters or that are created with a new construct. So it's not really like Erlang where you can send to any value like
Oh, I see.
something here. So it's less. Oops. It's less. Well, my names are not quoted processes as in Erlang. So,
but you have quoted. You have
yes,
quotes,
yes,
but
right.
they're not the same. Okay.
Well, it behaves the same, except, which is a big difference, you can't send and write to a quoted channel, to to a quoted process, because um, uh,
But what this means that you don't have this recursion between names and process, or
I do have one in my AST, but not in my I don't think I need to have something like the tuple space um, for my small toy language, because okay, here in my AST I got some processes that can be expressed by names. So yeah, okay, and I can have names that are quoted processes. So there is still a mutual recursion between the two types, but it's not as important as in Erlang, because you can send to something else than a channel created by new, or something that is a parameter of the current process.
I see.
So I'm not sure it's
Oh, this is why you
yeah.
need new in the process and also in the name, right?
Well, this was for syntactic sugar, so this was just for the example here. Okay, here, where I can put new response within a process, which would be syntactic sugar for this. Okay, this doesn't work. Okay, that would be syntactic sugar for the new here. That is, okay, yeah. For the new here, which applies on both processes, because response is also mentioned here. So I have to wrap both within a new response block.
Oh, this is
Okay.
like a new scope where
Yes.
response is available.
Yes. So here I would just have something to get from this process to this one. but it shouldn't be on the rules here. So yeah, I think I can delete this. Yeah. Okay.
Yeah, I definitely see this as a syntactic, sure. And in a sense, this is what Greg is saying. I think that this is when you poke a hole in your expression, right? You're making, in a sense, you have a free variable inside your expression, and you just somehow make it as a parameter, right?
Yes. Oh, right. So you can express that with continuation passing style, maybe. So with the cont monad in Haskell, I've never used it, but I just know.
Can you tell me? Now you mentioned continuation monad, but do you know this more general definition for CAN extensions? Because I was looking at that. This is like a generalization of continuation monad. But
no, I don't know this definition yet. I'm reading Bartosz Milewski lectures on category theory, but I'm not at that point yet, so I don't know the definition by CAN extensions, but yeah, I should check it out soon.
Yeah. Yeah, this is like an interesting subject, because you can define this recursive this isomorphism, right, between these two data types. This is what I'm looking. But
so you mean between cont RA and just A?
Oh, well, now you're asking too much.
Okay. You mean in isomorphism between what and what?
So let me try to find something. I was looking how to define this comonad, so I can only because there is a duality between for example, store and state monad, right? And I was thinking that maybe I can define this comonad and just turn it into monad and use recursion schemes to fold it. So parser will be unfold with this comonad, and this monad will be like a folding to get the co-events and everything.
So in the recursion schemes X package, like I said before, you have this one. So you want to fold with a monadic function here. So your fold R F no. You want to fold where F can have type B and B, right?
I'm not really sure.
You said that you wanted to fold with monads and unfold with comonads.
Yeah, and I really don't know exactly how to do it, but I have something. I was looking at example for from this guy that created PureScript, how to define UIs.
Oh yeah, yeah. I think I read the same paper. Yeah, it's
the future is comonadic.
yes, maybe yeah. So
And I found it very interesting, but I didn't figure out how to exactly use it.
yeah,
And I found that I found this library kind extensions from Edward Kmet.
Kmet, yeah, yeah.
But you know, I think every library from Edward Kmet is very difficult to understand.
Yeah, yeah, yeah. Yeah.
So there is an interesting co data type that can turn comonad into monad. But I couldn't make it to work in Haskell. Maybe I had there is no like defined isomorphism between state monad and store comonad. But
okay, so okay, yeah, I think I get what you're saying. So you're saying that with can extensions you can express the relation between a store and a state.
Yeah, exactly.
So and you would like to use them in your in the Rolang implementation.
Yeah.
Okay, yeah.
Much more in the same way as you are using in your project, but you are using reader T and the state T.
Yes. Right? Yeah. Okay. Yeah. I'm not sure that I can help you here because I don't know can extensions, but I will definitely read about it in the next days because
cool.
It's really interesting. Yeah. Yeah.
I will try also to make something, so maybe we can discuss the next time.
Yeah, sure, great. Cool.
Okay, should we wrap?
Yeah, I think so. At least I have nothing more to say. Yeah.
It was very interesting, and sorry for all of my questions. I'm very curious. Cool.
Great.
Very nice presentation. Thank you.
Thank you for inviting me and for your videos on row calculus, like the whole R-chain videos that made me discover the Discord server. So the whole project is really cool, and I really want to wrap my head around the row calculus, but I'm still having trouble with simpler calculus such as pi calculus. Like so I'm trying to do this toy project. Maybe
so
they will contribute to Rolang. Yeah.
So you're saying that you want to learn more about Rolang, and you're referring to your implementation as a simple calculus. But I seen it like a other way around. Well, for me, it's row calculus is more simpler than what you are trying to do.
Maybe, but it comes from my head, so it's simpler to me. But yeah, I guess I have to use Rolang in practice to get used to it, because I haven't done so yet.
Well, we certainly need help developing the community functions and the voter registration and liquid democracy contracts initially. If you can attend a work study and
yeah,
do some Rolang development.
Yeah, I followed a little bit of Josh's learned rolling by example repository on GitHub, and I also watched a few videos on the Chain YouTube channel. So there is a lot of resource on YouTube, and yeah, so I heard that you were organizing work studies, right?
Yeah, well, we're trying to realize some real applications while we learn and have fun
Oh
learning.
yeah, okay.
If
Well,
no, we put our heads together and develop something that serves the community.
okay, yeah. Well, I'm really interested in, as I said a few days ago, and at the beginning of this of our meeting, that I was interested in the game theoretical interpretation of process calculus. So, and I also wish, like, as a proof of concept, make some simpler a toy model of a chemical reaction through process calculus.
Yeah, I put some notes in about Chem Lambda.
Yes.
I'm very interested in the applications. I mean, the Chem Lambda can be used to simulate chemistry, and I'm wondering if putting that together with process calculus simulations of chemistry, if somehow the computation models can be linked. No, I'll put a link in there to. It's a very different kind of. They have nodes and they have edges, and they have beta reductions, they have fan-ins, they have fan-outs. You basically have translation or moves that they can make. And the nodes are decorated with lambda calculus or anything else, really, that can be reduced according to these moves. And it's molecular. It's a molecular model where it's the interaction of these molecules, so to speak, that are all computing independently that determine the algorithm. And they, it's there's examples, if you look at the demos, of all kinds of algorithms. I think that the tuple space representing that in process calculus is going to be very difficult. Whereas in the Chem Lambda, I think building on some of the examples that they have of data structures, you could build a structure that could match sends and
processes. Yeah. Right.
And why is difficult in tuple space?
Well,
why is easier with lambda calculus? Because of sequentiality of lambda calculus, or
right? But the graphical calculus is is a specific, well, I don't know. It's
or maybe because of reduction rules.
right. You know, by organizing graphs molecularly, it provides a way, you know, a natural organization of holons or systems, which provides.
So you mentioned.
It models the concurrency. And really, and the space.
I'm not quite sure where does concurrency pops up in the context of chemical reactions. Like, what would be the interpretation of par composition in terms of chemistry? Yeah.
Well, I mean, in a sense, everything's in par, but it's I guess edges.
Okay. Yeah. So processes would correspond to molecular bonds or something like this, maybe, that would exchange data through channels. I'm not really sure.
Yeah. I haven't looked into it in depth for a number of years, but
How you do?
I would be very interested in what you guys think about it.
Well,
yeah, I just wanted to say, how do you like to express chemical reactions?
I don't really know. I just wanted to. Well, my initial project, which led me to find rolling and stuff, was writing a type system for chemical reactions, and then I read about Petri nets, which is like the representation of a chemical reaction through diagrams which have a structure that is similar to process calculus, like to process algebra. And it turns out that there are many other connections between process algebra and linear logic and also Feynman diagrams. So you can represent Feynman diagrams with processes.
This is interesting.
I'm not sure I understand approximately 0% of this, but it's really interesting. Yeah.
I wanted to ask you about linear logic. So, as I understand, my understanding of the linear logic is not very big, but I understand that you have some restrictions of resources, right? In a
Yes,
linear
something
logic.
like that. Yeah.
And
But
do you want the same thing in your implementation?
well, uh, in my implementation, I it's very far from linear logic in in a sense that in linear logic you have like a whole bunch of composition operators that do different things, and they have a lot of relationship one to another. And here I just have the par uh, composition operator, which is much weaker than the whole linear logic as it is defined by Jean-Yves Girard in the original. Well, he's the guy who invented linear logic. But it turns out like I've been I've been reading about linear logic in the past days because I wanted to make my type system closer to it, but I don't know yet if that's possible. If what I've done so far is compatible. So yeah, I have a lot of open questions on this.
Did you see this paper that Greg was mentioned multiple times from Samson Abramsky, Computation and Interpretation of Linear Logic?
I don't think so. No.
Greg was saying that for him this was like very important paper. So
Okay, right. Well,
I can post it on the Discord. So maybe
yeah.
it's interesting for you. And if you find something out, please share.
Yeah, I have I found a paper on a type system which correspond exactly to linear logic, and but it's like 57 pages long, and it's really complicated, at least for me. So it's taking a lot of time to digest the whole thing. And but yeah, I I would like something that's close to what's described in the paper, or maybe exactly the same thing, and maybe I just start over. Yeah, I don't know yet, but
Cool.
yeah.
So do you interested that maybe we can try to write something that is similar to Petri-nets in Erlang? I don't know Petri-nets, but I would like to learn about it and maybe write some Erlang that simulates this kind of stuff. I think that Joshi would also be interested to do something like that.
Yeah, well, I'd be
So
glad
if you have some kind of example in Petri-nets, maybe we can just discuss it on Discord and maybe try to make.
Yeah, I don't have an actual example because I don't know either a concrete example of PetriNet that would correspond to an actual program, but in from what I've read, there is also a connection between proofs in linear logic and PetriNets. So the proof thing, like we can represent both chemical reactions and games and stuff like this. But so there is a way of representing processes by a diagram with like a network. Yeah. but in a more a general way than Petrinet, I think.
Greg was also mentioning this work by guys from Oxford, I think. They're working on quantum logic. And,
oh yeah.
This guy that works with Abramsky, they made some kind of general diagrams to express many things.
Okay, yeah. Well, I'd like to see the links to the article, please.
Yeah. Okay. I'll post it.
Yeah, yeah.
I'm interested what you think about it, and if you.
Well, I don't know about it yet, but on the N category lab website, there are a lot of mentions of quantum something, and but it's really theoretical, and I really don't understand much about it. So I'm not
You
sure.
mentioned this N category, N lab is a
Yeah.
site.
Yes.
Yeah, it's for me it's too difficult to read it.
Well, yeah, I've been on the same page for more than a week now, like a single page.
Yeah. And
It's
you
really...
probably heard from Bartosz Milewski that now they're not talking about the monads anymore. They just have two categories and that's it. Everything is two categories. So, like
from where? From
on NLab.
I'm not sure.
They're not talking about the monads in one category with the set.
Oh yeah.
About when you have two categories, so the set is like a whole thing.
Okay, yeah. Well, I don't know about this definition, but it looks really more complicated than it already is. Yeah.
But this link that you gave in Discord for with the deep inference,
yes.
And I was reading this, and in a sense, this is like exactly from type theory when you don't have equality based on sets, when you have equality based on something else, like graphs or because Greg was explaining that they want to have these collections not to be sets. When you evaluate the raw terms, you're collecting it not in a set. And
so it's what?
It's a graph.
It's a graph that represents what exactly, like the communications between channels.
Representation of equivalence between names and processes.
Okay.
And
okay,
I'm not sure that I understand this completely. And I wanted to ask you, you in your example, you're using algorithm W, and you're making this equivalence, right? When you want to unify and infer types. And what type of equivalence do you have? I'm not completely sure. Do you have sets or graphs or?
Okay, well, I'm not quite sure myself. I just tried to write something that type checked, but I don't know from a theoretical viewpoint how we could qualify this this equality. But the unification usually, well, I'm not sure how could equivalence be on something else than a set. Well, I'm not sure to understand your questions, because my equivalence is not really defined anywhere. It's mainly like the unify function that does the work, because I have a name equality at the end of the file, but it's just temporarily here, and so I don't have really a well-defined equivalence relations on processes. Yeah.
So my understanding is, and I'm relating this to reading that I have from deep inference, and so I see this distinction between sets and some other more complicated structure that you can encode not only just equivalence that is expressed with the sets, but also you can encode the behaviors. And in deep inference, they are describing this as rewriting anywhere in the structure. And I'm not sure what they mean, but they can make equivalence between different behaviors or different rewrite rules. And this is exactly what Greg was explaining in his lectures, how you can use bisimulation to make this equivalence.
I'm having trouble to wrap my head around bisimulation, because I don't really know what it means. Like, what does it mean exactly to have a bisimulation on processes? So
and
like what does it allow you to? What can you do more with a bisimulation? Yeah.
I don't have an exact answer and understanding, but he was saying that you can compare holes. So you can have a process with the holes, and you can extract these holes in a sequence that you can compare and say, okay, if I have two processes there that are the same, and I can compare it with the holes. So if I want to use it, I just put something in the holes that will type check, and I can run it. And with bisimulation, he's saying that you can make equivalence between these processes with the holes.
There's a simple model of that with process equivalence being trace equivalence. I mean, if they have the same behavior, they are equivalent, even if they're different. I don't know. But what we're using is essentially
traces.
So in a sense, when you collecting your types inside the context, you're not saying. Maybe this is not a good example. Maybe with the variables just. In normal function language that we use, we don't know where the variable inside the process, inside the function, or we don't know where it is. We don't care about it, right? Only the type. We care about only the type. But Greg was saying that we want to know where this process is inside this expression.
Right.
So you can compare it where it is, where it is inside. Where is this hole?
Yeah. So this should be captured by the type system you're using, because if you take not here.
But in a sense, you know that your function accepts integer, right? This is the type. This is the input type, but you don't know where this integer will be placed.
Yes. Yeah. So this is supposed to be represented by the sRead and sWrite sessions here, which can express like we sometimes describe linear type systems such as in Rust, where the function types carry the number of times that they consume their arguments. But if you have these sessions read and write, you can not only know how many times they're consumed, but when, by comparison of the other processes. So it's kind of more general, because you can have something that reads, then you can have something that reads here, then write to another channel, and then read something else. Well, it should be like this. Whereas in linearly typed functional languages, you would just have x, which is consumed 2 times.
Yeah.
And here you get this structure of the process through its type, basically. I'm not sure if
so you're
makes
saying
sense.
that the first x is you can differentiate between first x and the second x, right?
Yes, and I'm reading the channel x in 2 different processes, which is not really represented with the type system that linear Haskell use, which basically have the function types carrying an integer value that represent the so I can have this kind of thing. Let's say I want a function that consumes twice its argument, so I can write this. This is a pseudocode, but it should. So here I'm reading the 2x, the same x but twice. So I'm putting a 2 here, but I don't know in which order they're consumed. And in more complicated example, I can do like case x of So I can have a really more complex process, and that couldn't be represented by a type like this, because you don't know, like you could also say well, no, it doesn't work, but this gives a more precise scheme of what your process does, basically.
I see. In a sense, can we say that with the session you have some kind of a path that you follow, or does this make sense?
So some kind of what?
A path, a way to navigate to this structure. And
I'm not sure to understand, because my structure is is basically some combination of these main three sessions. And so I'm not sure to understand your question.
I'm thinking that if we know this information, how the variables are used, then we know how they are placed inside the process. I'm thinking of that.
Yes, well,
So
yeah. But this actually may be interesting when we want to have let's say when you want to detect at compile time when the processes use a reference so that you can manage the memory at compile time. So you can detect when the references are should be
garbage collected.
Yes, but it's not really a garbage collection, because you could probably do it at compile time, in the sense that you could insert in the bytecode the specific points where the channel should be deleted. Yeah.
Oh, I see. Yeah. In terms of linear logic, you can say more about how this variable is used, right?
Yes. Yeah.
Cool.
Could you guys wrap it up here? We got a work study.
Yeah.
Yeah.
Yeah, definitely. Would you like to participate in our session Friday or
Friday? Yeah. I have I'm a student, so I don't have a lot of time to do this, plus the work, plus the so I'll try to be there, but I'm not sure yet. But
okay.
Yeah.
Great. Okay, thanks for this whole presentation.
Yeah, thank you.
See you. Jim, thanks for recording. Bye.
Thank you. Bye.